Today's fighter pilots fly in complex technological environments. Survival depends on computerized systems that act as the aircrew's electronic eyes and ears.
Right now, the sensors or the information that's coming to us is all pretty much uncoordinated and is unprioritized. And what we're talking about here is to bring all that sensor information into one output.
Canada's F-18s have been in service since the early 1980s. In order to meet our government's commitment, the F-18s need substantial technological upgrades to assure continued support of our role and compatibility with our allies. One key system being modernized is the Mission Display Group, or MDG. However, traditional build, test, build approaches to system upgrades take time and are expensive and risky.
The older method of just creating something and seeing whether it's better or not does not actually tell you how much better it is or why it's better, or whether or not you hit the 100% solution or the 50% solution. Human factors engineering work with rapid prototyping will tell us where we are exactly on that.
To overcome these problems, the Defense and Industry Project Team, Litton Systems Canada, National Defense Aerospace Engineers, Defense R&D Canada, and CMC Electronics turn to human factors engineering and rapid hardware prototyping to demonstrate that flat panel liquid crystal display technology could help modernize the CF-18 MDG. The Department of National Defense has started using human factors engineering and rapid hardware prototyping to design and test new technology that saves time, money, and worry. It starts with a thorough analysis of the mission requirements, the environment in which the crews will use the equipment, and the tasks the operator performs. The crew's information requirements drive controls and displays generated by virtual reality software. A hardware approach for real equipment is selected, and the analysis and hardware work culminates in rapid prototyping. The Air Force used HFE and rapid prototyping to increase the effectiveness of displays for the CF-18 fighter aircraft and ensure compatibility with allied partners. Canada was the first international customer of the F-18 Hornet, with final deliveries being completed in 1988. Today, that version of the aircraft, called the AB model, provides defense capabilities to air forces around the world. The release of newer versions of the F-18, the CD and EF models, has led suppliers to discontinue support of some AB systems and has rendered selected components obsolete.
We need to be able to communicate. We need to be able to have our weapons compatible with, similar type weapons. If we're working with Army folks on the ground, and a lot of times we deliver weapons in conjunction with their assistance, again, we need communications and lasers and other things that are compatible. And if we don't provide those, we're not going to be asked to play.
DND has undertaken a multi-million-dollar modernization program to overhaul Canada's Hornets. New system upgrades, which include the Mission Display Group, will ensure that Canada's F-18s are compatible with the newer EF model. When the displays on the CF-18 were designed in the mid-70s, they were state-of-the-art in cockpit display technology. In order to meet requirement of the modernized aircraft, new color displays are a must. While most of the components needed to refurbish Canada's fleet are readily available, the Mission Display Group, or MDG, of the F-18 EF model is not compatible with Canadian CF-18s. Adapting it would have been costly and impractical. In the past, developing a major system like the MDG could take many years. Changes were expensive, and users frequently weren't involved in testing the system until its final stages. The slightest alteration could mean a complete redesign, resulting in further delays and expense. The rapid prototyping process allows engineers and flight crews to put innovative concepts through rigorous testing.
We took 4 key areas: the graphics video engine, the central processing unit, the high-speed digital video link, and the flat panel display itself. And we brought those together, and we were able to demonstrate that they could be integrated with each other and that they provided the performance that the customer was looking for and met the customer's expectations in terms of usability. And that's a key issue and a key advantage with rapid prototyping, is not only can you remove technical risk, you can also demonstrate that the product does meet the overall user environment for which it's intended.
Defense R&D Canada coordinated evaluations of the effectiveness of the MDG concept demonstrator. They brought in CMC Electronics, who had demonstrated its human factors analysis and engineering capabilities during a series of simulator tests conducted on the night vision goggle heads-up display for the Griffon helicopter. The NVG has since been accepted for implementation in Canada's Griffon fleet. While Litton Systems worked with Kaiser Electronics to analyze and test the commercial components to determine their suitability and to develop the concept demonstrator hardware, CMC Electronics analyzed missions, tasks, and information flow, creating software displays and a synthetic environment to put the demonstrator through its paces.
Having the aircrew participate at the upfront stage not only helps define the concept, the requirements themselves, the specification with respect to the prototyping, but enables everybody on the fly to make extremely rapid, proactive changes to, for example, in this particular circumstance, the prototype displays themselves. So it's not only risk reduction, it makes everything more cost affordable. It's a heck of a lot more efficient. It makes the process itself, it expedites it tremendously.
And who better to participate in the process of change than the end user of the MDG? The project team invited a group of pilots to participate in a series of assessments.
My input is important to the final product, but my input combined with others, plays an important role to the outcome of the product.
What I did is I took part in the validation trials prior to the actual trials themselves. And what I found based on this human factors engineering study is that I would have a tremendous improvement in my confidence level with respect to situational awareness. I saw an incredible increase in the effectiveness of the weapons platform just because of the information that we were able to synthesize. If I can use a confidence level, I would have perhaps 90% confidence level of what my situation was, as opposed to have perhaps 30 to 50% situational awareness or a confidence level of situational awareness in a similar scenario prior to these efforts.
Man and machine were linked in a synthetic environment. Pilots evaluated the new color displays and data formats under real-life conditions. Based on their feedback, the CMC Electronics HFE team adjusted data flow, display colors, and symbology, often within minutes.
We had a pre-planned mission, and we would go and fly that mission looking at the symbology set. When something would come up and we'd kind of go, yeah, we like that, let's keep it, and something else we didn't like, then we'd go and within a number of hours be able to change the part we didn't like, and then be able to do the mission again and assess whether or not it was better or worse. To be able to do that in a matter of sometimes minutes, sometimes maybe a day, is outstanding. We can make very large leaps and gains in our knowledge and our quality of our product over a very short period of time.
Test results demonstrated the viability of adapting commercial components into a display for the CFA team.
One of the advantages of being able to show representative hardware in a near representative environment is that it can be shown that the equipment itself is suitable for the purpose that the customer intends for it. And therefore you can avoid the unfortunate situation where an item can be specified and developed and ultimately be found to not be suitable, and therefore waste the investment that both the government has made, financial investment, investing the taxpayers' money, and in addition the investment that industry makes in terms of resources and engineering skills. So this is also something that having rapid prototypes, having representative hardware allows us to achieve, which is not achievable when you're doing effectively paper designs following a linear development process.
I think without the HFE analysis and the initiative, the rapid prototyping of that equipment, I don't think any of this would have been possible. I think a lot of money would have been expended, and at the end, the consumer probably wouldn't have been happy with the result.
As a result of the partnership between Defense R&D, Litton Systems Canada, and CMC Electronics, the life and mission capabilities of Canada's F-18s will be extended well into the 21st century. Research in this field is helping industry advance and develop promising new technologies and concepts. It's a futuristic solution that's benefiting Canadians right now.
Time and money are not areas of flexibility for us. And rapid prototyping gives us the ability to attack the time and money situation and get a proper solution in a very good amount of time.
Whether you're Army, Navy, or Air Force, you are looking at those systems, in a way that you'd like to be able to insert technology as you go throughout the life of the system. So I see this as an across-the-board type of process that the Canadian Forces should embrace.